Security baselines for containerized workloads in Azure provide a structured approach to ensure containers are deployed and managed securely. Containers are lightweight and scalable, but they require a focused security strategy due to their dynamic and often short-lived nature. Azure offers specific services and tools to help apply these baselines, protecting container environments such as Azure Kubernetes Service, Azure Container Instances, and Azure Container Registry. There are many key components of container security baselines in Azure. Let's unpack those. For image and registry security, you should ensure containers are built from secure and trusted images. You should use Azure Container Registry to store and manage container images securely, and enable image scanning for vulnerabilities using Microsoft Defender for Containers, which can scan images within ACR for known vulnerabilities and compliance issues. You should avoid using latest tags in production to prevent untested image changes from being deployed, and use signed and verified images only from trusted sources such as official repositories or approved internal sources. For network security and isolation, you should limit exposure of containers and reduce potential attack surface. You should use network policies to control communication between pods within AKS clusters. AKS supports Kubernetes network policies and Azure network policies for fine-grained control. Deploy containers within private virtual networks to reduce exposure and ensure that only necessary traffic can reach the containers. Use Azure Application Gateway with Web Application Firewall to protect publicly exposed services, filtering traffic before it reaches the AKS cluster, and implement Azure Front Door to further secure and load balance traffic to global applications. For access control and identity management, you should restrict access to container resources based on least privilege principles. Use Microsoft Entra ID role-based access control to limit who can access AKS clusters, ACR, and other container resources. Implement managed identities for workload in AKS so applications can securely access Azure resources without managing secrets. Enforce Kubernetes RPAC policies within AKS to control user and application permissions at the Kubernetes API level. Avoid hard-coded secrets in container images or code. Use Azure Key Vault or AKS secrets to manage secrets securely. For pod security and configuration management, you should enforce secure configurations for pods and containerized applications. Use pod security policies or open policy agent to define security standards such as disallowing privileged containers, restricting root access, and limiting host network access. Enforce container image scanning and validation before deployment by using admission controllers. Configure resource limits on CPU and memory for each container to prevent resource exhaustion attacks. Use read-only root file system where possible to prevent malicious tampering with the container's file system. For runtime security and monitoring, you should continuously monitor containers for suspicious or unauthorized activities. Enable Microsoft Defender for Containers to continuously monitor AKS for real-time threats, detecting suspicious processes, network anomalies, and other potential security breaches. Use Azure Monitor to collect and analyze metric logs and alerts from AKS cluster. This can help detect unusual patterns that could indicate an attack. Implement container insights for a deeper view into container performance, including CPU and memory utilization, node health, and more. And configure audit logs on Kubernetes API server and other Azure services to keep a record of who is accessing what resources. For data protection, you should ensure that sensitive data in containers is protected both at rest and in transit. Use Azure Disk Encryption for persistent storage attached to containers to ensure data at rest is encrypted. Enable TLS to secure data in transit for communication between services and external clients. Secure sensitive environment variable by storing them in Azure Key Vault rather than in plain text in YAML files or environment settings. For logging, auditing, and incident response, you should enable visibility into container activities and maintain an effective incident response strategy. Configure Azure policy with built-in policies for AKS, such as ensuring only approved images are deployed, enforcing HTTPS only traffic, and disallowing privileged containers. Use a Microsoft Defender for Cloud and log analytics to aggregate security logs, analyze them for patterns, and receive alerts on potential issues. Implement centralized logging and monitoring using Azure Monitor and Log Analytic Workspace to collect and store logs. Enable faster investigation and incident response. Develop a response playbook to quickly handle incident detected in the container environment with clear steps to quarantine, analyze, and remediate threats. For continuous integration and continuous deployment security, you should secure the container build and deployment pipeline to prevent vulnerabilities from entering production. Implement secure CI/CD pipelines with GitHub Actions or Azure pipelines, ensuring only validated images are deployed. Automate security testing as part of the CI/CD pipeline to catch issues early. And enable ACR content trust to sign and verify container images, ensuring that only approved images are pulled and deployed. Let's discuss the tools available in Azure for container security now. Azure Kubernetes Service is a managed Kubernetes service that integrates with Entra ID for RBAC, supports network policies, and integrates with Depender for containers. Azure Container Registry offers image storage and scanning capabilities with integration into CI/CD pipelines. Microsoft Depender for Containers provides vulnerability scanning for ACR images, real-time threat detection, and protection for AKS clusters. And Azure Key Vault manages secret keys and certificates which help to secure sensitive information needed by customers. So overall, security baseline for containers in Azure create a multi-layer approach to protect containerized workloads across identity, data, network, and runtime. Following these baselines will help ensure that containers remain secure, resilient to threats, and compliant with industry standards. Leveraging Azure's native tools and services will enable administrators to apply these security best practices more effectively and maintain a secure container environment in the cloud.